Hi everyone, this is Mr. Roach. I wanted to talk a bit more about some of the pre-algebra concepts that were covered today in Lesson 9, Session 3. This comes from problem number 6 of Lesson 9, Session 3. And what we're asked to do is we're asked to graph this equation. I would suggest going to this website here if you're wanting to graph. We talked about this briefly in the beginning of class today, and the website is called desmos.com. So that's a great website to go to if you are wanting to know how to graph something. We were talking today about negative numbers and how they operate with fractions, because sometimes we're finding our negative number might be on the top and it might be on the bottom for our slope. So for this equation, we don't have a negative slope, we have a positive slope. Let's work on solving this problem, and then we will talk about how the slope functions and how the line can go the opposite direction using a double negative with our fractions. Okay, so if we use the original equation, y equals mx plus b, we know that b is our y-intercept. We know that m is our slope. So in this case, m equals our rise over our run, which equals 50. By looking at our equation, we can see that it is 50. Now, please keep in mind that slope is expressed as a fraction, as rise divided by run. Sometimes we're given slope as a whole number, like when it's 50, in this case, and we can divide by 1. So 50 over 1 is the same as 50. All right, let's take a look at our y-intercept, or our b, and b is 125. We can also write our y-intercept as a point on the graph, and we can write it as 0, 125. Okay, so we're going to find 125 on our graph, and we'll plot a point there. In your books, I've noticed that we don't have graph paper for this, and that's okay. You can sketch a graph of your own. You can also use some grid paper that is provided in Canvas. Whatever works best for you. Please note that you will need to think about the scale of the graph. The scale of the graph determines how much each space will be worth, or the value of each space. In this case, the scale is 5. 105, 110, 115, 120, and 125. So each space's value is 5. Okay, let's go back to our slope. Our slope is 50, so we can go up 50 and over 1. If we go up 50, that will bring us to 175. And with this graph here, I've made every space equal to 5. However, we can change our x-axis so that it is different than our y-axis. I'm going to change these numbers. So that each space is worth 1. All of you have the freedom to change your x and y axis. Please make sure that your x-axis is consistent and your y-axis is consistent. Many times it's a good idea for those to be the same. So if one space equals 5 on the y, one space would also equal 5 on the x. However, that's not always necessary. So in this case, each space on our x-axis is equivalent to 1. Each space on our y-axis is equivalent to 5. So if we go up 50 with our rise, we're going to rise 50, which will bring us to 175. And then we're going to go over 1, which will put us at our new point right here. And that is our new green point. So that's the new point of our graph. We can connect these to create a line. Now, many times with linear equations, our lines are infinite. They continue onward. So we can get a general idea of the slope of this line, and we can continue the line a bit more in the upwards direction on the y-axis. So that's really what is asked of you of the assignment. For those of you who want to see a bit extra of how we might use slope in the opposite direction with the same slope, we're going to cover that next. So for positive 50 over 1, that also equals negative 50 over negative 1. Now, you might be thinking, why are we doing a double negative if that equals a positive already? It equals 50. That's a very good thought. The reason that we're doing a double negative is so that we can move in the other direction and we can start looking at what could be graphed in this direction. Because we've run out of room on our graph at the top, we can't really graph anymore, but we have a lot of room left over on the bottom of our graph, on the negative sides of where our x is. So each one of these is negative 1. There's negative 5, there's negative 10. Okay. So we can go in the opposite direction, starting from the blue point at our y-intercept of 125. We can now use our slope to move in the negative direction. So we can go down 50 by rising negative 50, which will bring us to -75 on the y, and then we can go -1 space on the x, which will bring us to our new point, and I'll do this in a different color, our light blue point right there. So that's how you can go the opposite direction. We can continue further if we want to, starting from the light blue point, and we can continue to use our slope. We can go down 50 again, and then we can go -1, which will bring us to a new point. We'll do that in a different color as well, to our orange point. And then we can connect these together. And so now we can see that we have more of our line drawn so that we can get a better idea of what this linear equation represents. The reason that the double negative is important is so that we can continue to draw our graph if it seems like we've run out of space and we have more room to be working with. All right, well, thank you everyone for watching, and I hope this was helpful. I'll see you later.